my wonderful students of Landmark Tutorial Center. We are here yet on another episode of our video lecture on physics. We are still discussing about the topic on equilibrium. We are done with the topic. We are just trying to solve numerous exercises that is in our textbook that relates to this area of equilibrium. So we have considered the conditions for a body to be in equilibrium, and we have said simply that for a body to be in equilibrium, that the sum of all the forces acting on the body must be equals to 0, which means that all the forces acting on the body must cancel each other. They must cancel themselves. That is the basic condition for a body to be in equilibrium. So here we have a very important question that will help us, which is found in our textbook, exercise number 7. Exercise number 7. It talks about a ruler on a level surface. So now the question says that a man uses a 100 kg ruler on a level surface and exerts a force of 196 Newton at an angle of 45 degrees on the what? On the ground. That is, this force makes an angle of 45 degrees on the what? On the ground. So, full stop. We are now required to what? To calculate the vertical force. The vertical force that will be exerted on the ground, assuming the force pulled, the force he applied pulled the what? Ruler. Or the force he applied pushes the what? The ruler. Now there's something you should understand is that once a force is applied on a body, if I apply a force on a body, the force I applied can be a force of push or a force of what? Pull. For example, if you want to remove a nail from a wall, all right, you don't have to push the nail. You have to do what? Pull it. Maybe by using what they call the Oxford hammer. Using your hammer or your plier to remove the what? Remove the nail. All right. So you have to pull that one. So force applied on the body can be a force of a pull or a force of a push. Now this problem here is actually a problem involving forces. When you are given any question or any problem involving forces, the first thing you have to do is to give the force diagram. The what? The force diagram of that particular problem. What do we actually mean by a force diagram? A force diagram is simply what? A diagram that displays the what? The mass and the what? And the forces acting on the what? Acting on the mass. So here, the mass here, the mass we are referring to is the what? 100 kg mass. And the force we are referring to here is the force, 196 Newton force, which is acting at an angle of what? 45 degrees with the what? With the on the ground. So now, assuming I have my what? The mass. Let me give the diagram. Assuming I have my roller, this is a roller. Okay, this is our what? Roller. And this roller have a mass, and then this roller, a man uses this roller on a level surface. Assuming this is our level surface, this is our level surface, the level surface. All right. Now, because this body have a mass, the mass of 100 kg, any body with a mass must experience a vertical downwards force. So this body or this mass must experience a vertical downwards force, which we call the weight of the mass. And this weight is equal to the mass times the what? Gravitational acceleration. So ordinarily, without any force being applied on this mass, this is the only force that will be experienced by this body. This is the only force that will be what? Experienced by this body. Let's forget about the normal reaction for now. All right? The weight must always be there. Okay? Then, the question now is that the man uses this roller, this 100 kg roller, on this level surface, and he did what? He exerted a force of how much? of 196 Newton. He exerted a force of 196 Newton on this roller. So let's assume that maybe he exerted a force. He now had to apply a force. He exerted a force. This force he exerted can be a push or what? A pull. Do you get the stuff? The force can be a push or what? A pull. So we don't yet know the type of force that was exerted on this roller. Let me draw it well. This is how it goes, like this. So the force can be a push or a pull. But the first question says that assuming the force he applied pulled the what? Pull the roller. So if it is pulling it, this force have to, the direction of this force must be in this direction. So the force of pull will take this way. So assuming I'll have the force of 196 Newton F pulling this roller, okay, towards this direction. And this force is pulling this roller. This force which is pulling this roller makes an angle of what? An angle of 45 degrees with the what? With the ground. It makes an angle of 45 degrees. Okay, the force was applied at this, at an angle of 196 degrees. It was applied, it exerted a force of this at 45 degrees on the what? On the ground. At 45 degrees on the ground. That is this angle here, our angle here, 45 degrees is equals to 45 degrees. That angle there is what? 45 degrees. So what again are we having? Because this is the ground. This is the ground. So the force exerted, that was exerted, makes an angle of 45 degrees on the what? On the ground. So you can take that as 45. And of course, if this angle here is 45, this angle here should equally be what? Should equally be 45 degrees. Right? Should equally be what? 45 degrees. Okay. Then, what do you want to find? Now you observe something. If we take this line or this axis as our x-axis, this is our x-axis, and this axis as our y-axis. So you can see that this force of pull, the force of pull, is acting in this plane. This plane actually is made up of the y-axis and the what? And the x-axis. The y-axis and the what? X-axis. So which means that this force is acting in this plane, made up of these two axes, vertical axis and horizontal axis. Therefore, this force should have horizontal components and the vertical component. Let us take the horizontal component as f sub x, and let us take the vertical component as f sub what? Sub y. Now, from our previous episode, we know how to resolve forces horizontally and vertically. Because from this note here, you can see, if we consider this line and this line, we can use these two lines to produce a right angle triangle. Right angle there, triangle. And in this right angle triangle, this side is the hypotenuse, and this side is adjacent to this angle. It is what? Adjacent to this angle. So therefore, these two sides are what? Related. This is the hypotenuse, and this is the what? Adjacent. So from this triangle here, you can see that the side, this side, which is our 196 Newton, is the hypotenuse of the right angle triangle produced. And then this side, which is the what? Which is adjacent. The side fx is adjacent to who? To angle 45 degrees. But we know that there is a relationship between the hypotenuse and the what? Adjacent side of a right angle triangle, which we call what? Cos. So of course, it therefore means that the cosine of this angle, 45 degrees, will simply be equal to the adjacent side given as f sub x over the hypotenuse given as 196. So if I now cross multiply, what I have is, this now means that our f sub x will now be equals to 196 cos 45 degrees. So that is just this. So this Fx will give us 196 cos what? 45 degrees. So when I resolve this force horizontally, I will get 196 cos what? 45. Please note, if this roller rolled horizontally, it is not this force. It is not this 196 force, 196 Newton force that caused this roller to move horizontally. It is this Fx, which is the horizontal component of the force, that caused this object or this mass to move horizontally. In the same way, if this object or this mass move vertically upwards, it is not this 196 Newton force that is actually responsible. It is just the component, the vertical component of this force that will cause such kind of a vertical motion. That is why we have to resolve this force horizontally and what? Vertically. To find the component of this force that is responsible for the horizontal motion and the component of this force that could be responsible for the vertical motion of this mass. So having found that our F sub x will give us 196 cos 45 degrees, we can equally show that our F sub y will give us 196 sine 45 degrees. Now watch, to do that, I will reproduce this diagram in another form, because if I reproduce this line along this side, look at this, I reproduce this line here, okay? If I reproduce this line here, so you can then see that this angle here, our angle here is 45. So therefore, this angle here should equally be what? 45 degrees. Who can give the reason? Because this angle and this angle here with this angle here, they are what? They are alternate angles. So if here is 45, here should be what? 45 degrees. And again, when we look at this, we want to resolve what? We want to resolve vertically. We want to resolve vertically. That is, we want to find this vertical component of the force, F sub y. But from this diagram, you observe that we have formed a right angle triangle, whereby this side is the hypotenuse, and this side is now the opposite side to this angle. But remember that there is a relationship between the opposite side to an angle and the hypotenuse in a right angle triangle. And that relationship is called what? Sine. So what it simply means is that the sine, it simply implies that the sine of this angle here, 45 degrees, will simply be equals to the opposite side to angle 45 degrees over the what? Over the hypotenuse, by definition. And that will simply mean that, our sine 45 degrees will be equals to, who is the opposite side there? The opposite side here is, to this angle is what? Is F sub y over, who is the hypotenuse? Is our 196. This is over 1. Such that when you now cross multiply, when we cross multiply, what do I have? If I should cross multiply, I think what I will have that this will now mean that, F sub y will be equals to 196 sine 45 degrees. So we have been able to get the horizontal component and the vertical component. This is 196 sine 45 degrees. Okay? Okay, we can finish up now. This will now give us F sub y will now be equals to what? 196 times sine 45 is root 2 over what? Over 2. And that will give us F sub y will now be equals to what? 2 cancels F1, 2 cancel this, into 18 is 9, into 16 is 8. So it is now 98 root what? Root 2. The same thing will happen here. This will give us F sub x will equals to 196 times root 2 over 2. And that will simply give us 98 root 2. So both will give us 98 root 2. But finding the horizontal component of this force of pull and the vertical component of this force of pull does not actually answer the question. The question just says we should do what? we should find the vertical force that is exerted on the what? On the ground. The vertical force, the net force. The net what? Vertical force that acted on the what? On the ground. So that means that we have to focus only on the what? On the vertical forces that acted on this body. Now, there are two vertical forces that acted on this body. The one is the weight acting downwards. Then two is the what? Is the vertical component of this force of pull. The vertical component of this force of what? Pull. All right? So, of course, we want to find out the net force, the net vertical force that acted on this body. You can see that this force, F sub y, and this force, W, the weight, they are acting, they have a common line of action. They have what? A common line of action. What do I mean by that? They have a common line of action. If two forces have a common line of action, who can remind me what they are called? When two forces have a common line of action, what are they called, please? Very simple. Whenever two lines have a common line of action, they are called collinear forces. Co-what? Collinear forces. The word co means common. Linear means what? A straight line. So you can see that this force and this force, they have a common line of action. They have a common line of action. So they are, therefore, they are what? They are collinear. And of course, we know that when two forces are collinear, they can either act in the same direction or in opposite what? Direction. But in this case now, this force and this force are acting in opposite what? Direction. They are acting in opposite direction. When two forces are collinear and they act in opposite direction, their net force will simply be equal to the bigger force minus the smaller what? Force. Now, suppose, watch. Suppose that here we have two forces, vertical forces, acting. The weight and the what? And the vertical component of this force of pull. Now, if the weight is more than the vertical component of this force, which is F sub y, all right, the net force will act downwards. So therefore, the net force, F net, the net vertical force that acted on the ground will now be equal to, due to the fact that the weight acting downwards is more than the F sub y. If the weight, I repeat, if the weight acting downwards is more than this F sub y, the vertical component of this force of pull, then the net force acting along this line must act downwards. So therefore, that net force is now equals to the weight, the bigger force, which is the weight, minus our F sub what? Y. And that will simply mean what? The F net will be equal. Please, why we are subtracting here is because this force and this force, they are acting in opposite direction. And they are collinear. When two forces act in opposite direction and are collinear, to find their net force, we simply what? Subtract them. But if they are collinear and they act in the same direction, we do what? Their net force can be found by simply what? By simply adding them up. So here, we have to find the net vertical force by subtracting the weight from the what? From our F sub y. And that simply means our weight, of course, we know, is giving us the mass times the gravitational acceleration. Then minus our F sub y we got is giving us 196 cos 45 degrees. And that now means that the net vertical force acting on the ground due to this force of pull will simply be equals, the mass was given, the mass of the body was given as 100 kilogram times, our G is always 10, minus 196 times, cos 45 is given as root 2 over what? Over 2. So that this guy will take care of this guy, giving us something like 98. So what we now have is that the net force, the net vertical force, will now be equals to 1000 minus 98 root what? Root 2. I think when you resolve this, the answer you will get should be what? Let me confirm this using my calculator. All right, so this will give us 1000 minus 98 root 2. And the answer goes this way as the answer gives us the net force will be equals to 861.41 Newton. 861.41 what? Newton. So this will be the what? The net force that will act on the what? On the ground. This will give us the what? The vertical force that will be exerted on the ground if the guy pulls the what? The roller. Then in the second part of the question, we are going to look at what? The force, the vertical force that will be experienced. The vertical force that will be what? Experienced on the ground if he pushes the what? The roller forward. In that case, we now give a different diagram for that. Okay, this can be cleaned. All right, so now in the same second part, II, we consider the same roller again, and then take our horizontal or level surface. This is our level surface. Our level surface, the level surface, which is our x-axis. That is our x-axis. Normally taken as our x-axis in this case. All right. And if this is our x-axis, I think this should now be our y what? It should be our y-axis. But before I put the y-axis, okay, let me just put it. This is our y what? Axis. This should be our y-axis. And then again, from the question, it was mentioned that the body has mass. It has mass. The mass is 100 kg. And since this body has mass, it must experience a vertical downwards force. A vertical downwards force, which is equivalent to what? To the weight of the body. And the weight of the body is normally given as the mass times the what? Gravitational acceleration. Then what then happens? It is now mentioned that assuming the man exerts a force of 196 Newton on this mass. So assuming he exerted a force of 196 Newton. And I told you a force applied can be a force of pull or a force of what? Push. But this force was applied at an angle of 45 degrees on the ground. At an angle of 45 degrees on the what? On the ground. An angle of 45 degrees on the ground. So this is our 45 degrees on the ground. All right? So then, what again do we have? So of course, we are now taking the second condition that assuming that what? That the man pushed, the force he applied was the force of push. If the force was a force of push, the direction of the force should be towards this direction, this way. A force of push, like this. Okay? A force of push. Then if this force is directed towards this way, the force, of course, we have seen is lying in this plane, because this plane now is made up of our x-axis, our y-axis, and our x-axis. Which means that this force of a push should have both vertical components and a horizontal component. Both what? Vertical component and what? A horizontal what? Component. But what should not be the direction of the horizontal component of this force and the vertical component of this force? Very simple. The direction will also be like this. It will also be this way. And this one will move like this. Move towards the negative direction. Had if it was a pool like this, this guy, our f sub x, will be directed towards this way. And Fy will be what towards this positive direction. But since this is now a push, like this guy will act like this, horizontally, and this guy will act like this downwards, vertical. So now, we have known how to resolve it now, horizontally and vertically. If you resolve horizontally, what you get is 196 cos what? Cos 45 degrees, we have done it. For vertically, what you get is what? 196, this is Fy, equals 196 sine what? Sine 45 degrees. That is what we get for the vertical component of the forces. Now, we want to find the what? The resultant of the vertical forces. The resultant of the what? Vertical forces, or the net vertical force that acted on the what? On the ground due to this force of a push. Due to this force of a push. So what it means is that we have to only concentrate. We have to only concentrate on the what? On the vertical forces that acted on this body. The vertical forces that acted on this body. So the vertical forces acting on this body are the weights acting downwards, and the what? And the vertical component of the force of a push. But you observe that these two forces, this guy and this guy, they have a common line of action. They have what? A common line of action. So therefore, they can be called collinear what? Forces. But in this case, this force, W, and this force, they have the same direction of action. They have the same direction. When two forces are collinear and they have the same direction, their net force is simply gotten by adding their what? Their forces. Just like, for example, you are moving towards this direction and somebody comes to your back and pushes you in the same direction. What happens? You will observe that your speed will do what? Will increase. So therefore, what happens is that what? Is that if I want to find the net force, the net vertical force on this body, since these two forces acting vertically have the same direction, their net force will simply be equal to their what? Their sum. So therefore, the net force F net will simply be equal to our W plus our F sub Y, which means that the net force acting vertically on this on the ground will be equal to the weight is given as mg plus the vertical component of this force of push now is given as what? Is given as 196 sine what? Sine 45 degrees. And this is what? Our F net will now be equal to our M is what? The mass is 100. Our G is 10 plus 196 times. Sine 45 is what? Is root 2 over 2. And if that is the case, we can then finish up this problem as F net will now be equal to 1000 plus, this can cancel this, 98, so it gives us 98 root what? I think the answer should now be that the net force will now be equal to what? 1098 root what? Root 2. Well, you can give the answer in decimal point as what? As this is 1000. Okay, let's this 1000 plus 98 root what? Root 2. Let's see what we have as an answer. All right. So this is just giving us that the net force should be equal to 1138.59 or 0.6 Newton. So the two forces we got for the first case, we got the force as what? We got the answer as what? I've forgotten. This is what we got was 1000 minus 98 root 2. It gave us what? It gave us 861.4 Newton. And the second one we got now as 1138.6 Newton. So these are the two vertical what? Forces that will be exerted on the what? On the ground due to this force of push and the force of what? Pull. All right? That is exerted on the ground at an angle of what? 45 degrees. But in the question, the options provided, let me read out the options provided here. The options provided are, option A says, the fixed force, the force of a pull will be 861.4 Newton, and the other one will be 1138.6. That is option A. I think option A is the correct answer to the question without much panic or much stressing of words. So thank you for joining me in this episode. The next episode we are going to conduct a critical examination on the issue of what? Moment of forces. Moment of what? Of forces. And we're going to solve so many tedious examples on that particular what? Topic. Not only on that particular, the issue of moment also cuts across this area of what? Equilibrium. All right, it's also under what? Equilibrium. So we have about close to 6 different questions we have programmed and solved on that particular area. So as you can see, I have my own book where I solve my problems at home. So in your own, at your own leisure time, you also create your own time to solve problems. So as you watch the video lectures, you try to understand what we are actually trying to solve, how we are solving the problems. Try to understand it in your own way. And try to pen down, write down your understanding, the way you understood the solvings, you write it down. So that in the previous, in future, or in time to come, you can go back to your note before resumption. You can go back to your note and do what? And then revisit what you have actually understood in the previous video before you have to delete the video. You don't just watch video and then discard it or delete it. No. Don't delete the video until you have understood the topic, until you have understood the solvings in that video lecture. And when you have understood the solvings in the video lecture, the next thing you have to do is what? You have to use your pen and take your book and then write down your understanding of that particular word solving. The way you understood it, write it down properly well. So I have my own solvings here. These are my works which I solve each day after day on all the questions you have in your exercises in your textbook. So I'll be dishing out these things I have solved here as video lectures just to equip you at home. So please do not neglect all these things we are doing. I'm just trying to stress myself for your own benefit, for your own good. If you have any question to ask me, please do well to do what? To send the questions on the group chat, or you can even chat me up privately. All right? Chat me up privately. I will always be there for you. So thank you for your patience and your understanding. May God bless you all.